Okay, so you can compare this to what you have, and you may have gone about the process a little bit of a different way, but I want you to see one way that you could think around the circle. So we know that this is 0 or 2 pi. Hopefully we can get all our quadrantals. What's this one? Pi over 2. This is pi, and this is 3 pi over 2. Okay, and then the first quadrant we've all got down, right? What is the 30 degrees? Pi over 6. 45 is pi over 4. And 60 is pi over 3. Okay, so we got that. All right, so we know then that there's a ton of reflections, and so we know that whatever the angle is, this is our pi thirds, this is our pi fourths, and this is our pi, sorry about that, this is our pi sixths. Okay. Now, one way to think about it is, yes, in the second quadrant, the numerator is 1 less than the denominator, but also you're not always going to be filling out the entire circle. So one way to think about it, when you're trying to figure out the pi 6 angle in the second quadrant, if I'm thinking in 6, this is 6 pi 6, right? So I back up 1, and that gives me 5 pi 6. For 4 pi, for the fourth, right, this is 4 pi over 4, so I back up 1, and that's 3 pi over 4. I'm at 3 pi over 3, I back up 1, and I'm at 2 pi over 3. Does that make sense? That's how I think about most of them, is what's happening from the horizontal, and then I go up or down 1. So then when I'm coming down here, the first one is going to be a pi 6 angle. This is 6 pi 6. That makes this 7 pi 6. That's why the numerator is 1 more. This is going to be your pi fourths. This is 4 pi fourths, 5 pi fourths, right? And then this is going to be your pi thirds. So this is 3 pi thirds. That makes this 4 pi thirds, right? And then 5, 7, 11 can get you through this one, but you could also think about being here and going backwards. If this is your pi 6 angle, this would have to be 12 pi 6, so you back up 1, you're at 11 pi 6. This would have to be 8 pi fourths, so you back up 1, you're at 7 pi fourths. This would have to be 6 pi thirds, so you back up 1, and you're at 5 pi thirds, okay? So I think most of you got the radians in there, you were fine, right? Just different ways to think about how to get there, because you're not always filling in the entire circle, okay? All right, so then we go and we do all of our ordered pairs, right? So what is this one right here? 1, 0. What is, so then here we can use our hand trick, right? So this is going to be the square root of 3 over 2, and then what? 1/2. And then this is going to be square root of 2 over 2, square root of 2 over 2. Then this is pi thirds, so this is 1/2 square root of 3 over 2. And what is this ordered pair? 0, 1. All right. All right, so then here, what is this? Negative 1, 0. And what is this one? 0, negative 1. Okay. All right, so then all of these are reflections of each other, right? So these 3 points get reflected over here. I'm not going to take the time to write them all out just because, but the ordered pairs, what's positive, or I'm sorry, what's negative here, the sine or the cosine? The cosine. So this is negative, positive, right? Negative, positive, negative, positive, and it's just a reflection of those points, right? It'd take me forever to write it all out, and I know most of y'all have that. What about here? What's negative here? Both of them. Negative, 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 right? They do look like little faces. And then what's negative here? Sine or cosine? Sine. So it's positive, negative, and positive, negative, right? So let's talk about tangent. I'm going to give you a way to remember your tangent values that I actually learned from a student from another teacher that I'll show you. When I'm here, first of all, what's the tangent of 0 or 2 pi? 0, right? What is the tangent of pi halves? Undefined, right? All right, so then what's the tangent of pi fourths? 1. It's the easiest ones, right? Then you have the square root of 3 and the square root of 3 over 3. Well, the two 3's make a 6, so this is the square root of 3 over 3. And then this is the square root of 3. So then just like the others, these all reflect. For tangent, is tangent positive or negative in the second quadrant? Negative, because you would put positive over negative, right? Is it positive or negative in the third quadrant? Positive. And positive or negative in the fourth quadrant? Negative. Okay. Everybody good with that? What questions do you have? Anything? Not yet. We're not there yet. Shh. Exactly. Just like the sign in quadrant 1 and quadrant 2 is the same, right? Because they're both positive. So yes, the tangent values in quadrant 1 and quadrant 3 are the same. Yes. Good. What other questions do you have? Anything? Okay. Awesome. All right. So then you can erase this. No, you can use the little eraser. I put little paper towels on your table too, because the little tiny eraser takes forever. And then, I mean, it works well. It's just, depends on whether or not you want to use it. If you'll put the little paper towels I put on there, whether you use them or not, put them in that little green basket for me too. And then grab this. Okay, so get your little reference. You got this yesterday. This is going on page 85. Some of you may have already put it on there. We didn't get to it yesterday, but it's what goes on page 85. And it's mostly filled out because I wanted you to at least have to fill out something else. The degrees are there, the radians are there because you're going to rewrite them a bazillion times. At least they're in there and they're in there correctly. I want you to go ahead and look at this and fill in the rest of the ordered pairs. Now notice that we have, well actually let's do a little bit of this together. What's this ordered pair right here? 1, 0. This one right here is 0, 1. This one is -1, 0. This one is 0, -1. Those are actually the most missed ones eventually. Yes, because they're the easiest and y'all don't know how to think about X and Y and you just say the wrong thing and you're not even thinking about it. So think about it so you don't mess them up, okay? Then if you look at the rest of the ordered pairs, they are all over 2. For this particular thing, I put the over 2 on there so you can kind of see that. Do not make you think that moving forward, all you have to do is give me the numerators, okay? The denominator's still part of the number. All right, so now you go ahead and fill in the rest of these and pay attention to your signs. And then we'll talk about it and you can double check what you have with what I have up here. Use your hand trick if you need to in the first quadrant. Okay. So, do you agree with what I have, signs and all? Right. Yeah, it is kind of hard to see. But if I make it, problem is when I make it, you can only see half at a time. I know, woo! Okay, and then it looks like all squiggly because I was writing so small. But in the second, so this is what we have in the first quadrant. If you can get your first quadrant right, then you're just reflecting. The second quadrant, the only ones that are negative are the cosine values, right? And then they're both negative in the third quadrant, and then your sine values are negative in your fourth quadrant. Okay? Are we all good with all of that? Okay. Mm-hmm. in the second quadrant, it's always your x that's negative in the second quadrant. It's the same rules that you've always had with graphing. Okay. It's just your y that's negative because x is still positive. Okay, so let's look at, even though I've just talked about which ones are negative, we're going to look at which ones are actually positive. This is how you need to think about it, because you're going to need to know not only what are the, which quadrant you're in, but know your first quadrant values, and then we're going to put all this together. So in quadrant 1, which values are positive? Because we are looking at the positive values. What's positive in quadrant 1? Is it sine, cosine, or tangent? Or which is positive? All of them. So they are all positive in the first quadrant. Okay? In quadrant 2, what is positive? Sine. Is tangent positive? No, because you'd have positive over negative. So it's only sine and its reciprocal, which is what? What's the reciprocal? Cosecant. Okay? Quadrant 3, what is positive? The tangent, because sine and cosine are both negative. So tangent and its reciprocal, which is what? Cotangent. Quadrant 4, what is positive? Cosine and what? Secant. Okay? So I want you to draw a little tiny x and y axis right here, and then write out all students take calculus. Okay? All students take calculus. That's how it helps you remember this. It's like SOHCAHTOA type of thing. So you start in quadrant 1. All students take calculus. So when you want to know in the second quadrant what is positive, it's the sine values and its reciprocal, right? Tangent and its reciprocal are the only things that are positive in the third quadrant. Fourth quadrant, it's cosine and its reciprocal. They're all positive in the first quadrant. So if you can write down all students take calculus, then you're good. Okay, we good? All students take calculus. That tells you what is positive in which quadrant. That is super important in order for you to put all of this stuff together. Okay, we good? All right. Now let's look at these trig values over here, and we're going to write unit circle trig values. So it's not just any of them. It's when we're talking about the unit circle. So sine theta is opposite over hypotenuse. Therefore, it is y over r. But for the unit circle, the radius is 1. So sine is just what? Y. And cosine is what? X. Okay, cosine is x. What about tangent? Y over x. So it's y over x, which is also sine theta over cosine theta. So cosecant is what? What would I represent that? 1 over y. So reciprocal of sine. And secant would be 1 over x. What would cotangent be? X over y, or cosine over sine. Everybody good with all that? What are we not good with? We're good. Okay, so now I want you to grab the sheet you picked up when you came in, and on the top of that sheet, I want you to write this down. We'll talk about that in just a minute, okay? Just write that down across the top, or across the side. You can turn it and put it sideways. That's fine too. Just write that down, and I'm going to explain to you what that means. I know you didn't do this because I just had a student tell me about it the other day. So I have a student that was at at Pearland High School for the first couple weeks of school, and they handed him the unit circle and said, we're going to start quizzing you next week, and then they didn't do anything with it because they were just, I guess, making them learn it, which we've thought about doing and probably should have, but didn't. But anyway, so she said that he gave us a way to remember the tangent values, and I was like, I have never heard that before. He must have made it up. She said he did. And actually, I emailed him today, and I said, hey, I have Amber Wynn in class, and you had her for a while. She showed me this, and so I just wanted to let you know that I stole it and I'm using it. So thank you. And I said, I even had her explain it to the class today. So he was like, yes, I did make it up when I was in college because I made up some really weird stuff to help myself remember things. So anyway, this is going to help you remember your tangent values, maybe. I mean, there's different ways to remember it, but this is one way to get your tangent values written down for your first quadrant. So you don't have to draw this because you have a circle there, but I'm just going to draw kind of a first quadrant here. So you can actually do it on the circle that you have. But let me explain to you what this means. Every time you say R or use a word with R, which is like R and really, you make a little square root sign. So U stands for undefined. R, because the square root sign kind of looks like R, right? You are one really overwhelming third wheel. And then under the square roots, you put 3s. Those are your tangent values. You are one really overwhelming third wheel. So that it works. I think it's kind of ingenious, but again, knowing the 0 and the undefined, if you understand 1 over 0 and 0 over 1, which you should, that's no big deal. The pi fourths being 1, I mean, come on, it doesn't get much easier than that. And then the 2 3s for pi 6 and 1 3 for pi thirds. I mean, there's other ways to look at it, but if that right there helps you, there you go. That's just one more thing. One more tool in your tool belt, right? What questions do you have? Okay, I want you to take out the assignment that I gave you yesterday. And we're going to look at that a little bit. And then I'm going to give you the assignment for today. And we're going to look at that one a little bit. Ooh. So, for this one, and I said this yesterday, but I just want to make sure that you understood. I wanted you to fill this out without looking at anything, right? Without looking at your notes or anything else. Fill in all of the radians, all of the ordered pairs, and tangent values that you could. And then check yourself, but do it without looking first. Then on this side, I may or may not have worked a couple with you. Did we? Yeah. I think I did, but I'm not sure. But I'm going to do it again anyway, just in case. So when you're looking at this, and we want to find the exact value of each trig function, when we start with number 3, we use that hand trick, right? It is pi fourths. So using your hand trick, this is pi fourths. So you have square root of 2 over 2 and square root of 2 over 2. The cosine value is the first one, so the cosine of pi fourths, square root of 2 over 2. That's your answer. Okay? So then let's look at number 1. 5 pi thirds. What is the reference angle for 5 pi thirds? Pi over 3. It's pi thirds, right? So for your hand trick, pi thirds, this is pi thirds, right? This is cosine, this is sine. So the sine is the square root of 3 over 2. But that's of pi thirds, but we're still going to write it down. Square root of 3 over 2. But I'm not in quadrant 1. So I have to figure out what quadrant is 5 pi thirds in. It's in the 4th, because 6 pi thirds is 2 pi, and you back up 1. So we're in quadrant 4, right? I'm in quadrant 4. So then I have to think, all right, well, I know that I have this all students take calculus. So that means that the C means that cosine is positive in the first quadrant, right? I'm sorry, cosine is positive in the 4th quadrant. So sine is what? Negative. So your answer is negative square root of 3 over 2. Okay, we okay with that? Let's look at number 4. Tangent of 5 pi 6. What's the reference angle? Pi 6. So that means that for pi 6, the tangent value is the square root of 3 over 3, because it's got 2 3's in it to get to the 6, right? 5 pi 6 is in which quadrant? The 2nd quadrant. In the 2nd quadrant, is tangent positive or negative? Negative. So your answer is a negative square root of 3 over 3. Do you see how that works? Ask me questions. You got questions? All right. Flip this over. Let's look at this little maze. So we start here. We start at sine of pi halves. What is the sine of pi halves? Pi halves. 1. 1. So that means I shade in my 1 and I move on to this box. Make sense? Okay. So now and that's how you go through it. But now I want you to just dump to this box. You're not even going to get to this box, but we're going to do this one. Okay. So we want the cosecant of pi 6. Cosecant is the reciprocal of what? Sine. It is a reciprocal of sine. So what I need to figure out is the sine of pi 6. I use my hand trick. This is pi 6. What is the sine of pi 6? 1/2. But I want the reciprocal of that. What's the reciprocal of that? 2. So your answer is 2. Do you see how you have to think through the process? Like there's not any work, but there's thought process that you have to go through and manipulate things. Okay? We go and 2 is not an option because you don't get to that box anyway. But if it should be, if it was somewhere you would get and you would go in that direction. Okay? Everybody okay with that? All right, so now let me hand you so this one is, the pink one is due Monday. Let me give you the one that's due Tuesday. Neither one of them should take too terribly long, and you can check yourself. But if all you do is copy all of this directly from your unit circle, you are learning nothing, okay? And then you will be one of the ones that's complaining about this and struggling. You have to force yourself to think about it on your own. You can always check yourself and make sure you're doing it right, but you got to actually do the thinking. Okay, so on the salmon one, there's another one of these where you fill it out. Fill out everything you can fill out, okay? And then check it to make sure it's right. And then when you're doing what's to the left of it on both of them, fold it in half so you can't see it. You want to try and figure these out without looking at anything, with only using what you have in your brain and your hand trick, okay? On the other side, it's the same type of thing as it is on the big side of the pink one. Just some different ones that might even repeat themselves. Okay. Now I want you to look at this circuit here. So everybody be here. Don't be trying to fill things out. Okay. We got the circuit. So on number 1, it says find sine of pi fourths. So with your hand trick, what is the sine of pi fourths? Square root of 2 over 2. That's the answer to number 1. So then you've got to find that answer. So when I look for that answer is there. So now this is number 2, and I put a 2 in the blank. And then I want to find the cosine of 7 pi 6. All right, well, what's the cosine of pi 6? Square root of 3 over 2. And what quadrant is 7 pi 6 in? It's in the 3rd quadrant. 7 pi 6 is in quadrant 3. So in quadrant 3, is cosine positive or negative? Negative. So your answer is negative square root of 3 over 2. And then you move to the next one, which is number 3. This is a self-checking circuit, and so is the maze, really, because you should get through all of them in the circuit, and the answer should be there. So if they're not there, then you're wrong. I mean, and if you didn't get to one or something else happened, something's wrong. So because you should get through all of them. Okay? Do you understand what to do on all of these? Okay? Make your brain work. You can do this.